Hello, this is Slavo from Tweakstreet. Today I'll be looking at our weekly challenge number 2, which involves Roman numerals. We are given decimal numbers and we want to convert all of them to Roman numerals, which first we have to figure out how to do this. One idea, the most straightforward idea that I found in terms of algorithm, is on rapidtables.com, and it suggests the following. We start with the number we have, x. We use this lookup table to find the highest number that is equal or less than our number x, and we take the corresponding Roman numeral, append it to our result, and then we subtract the number that we found from our x. And we repeat that until there is until x reaches 0 value, at which point we are done. And there is an example here. We're getting the 1000 out of the way, then we're getting the 900, which is cm. So we end up with MCM, and then we have 96 left. So we take 90, which is XC, we append it. We're left with 6, so we can again take the 5. We're left with 1, we take the 1, and we end up with the result. So let's just apply this algorithm to our problem and see if we can make it work. Now the first thing I think I'm going to need is this table. This lookup table. And since order is important, I'm just going to use a list of dicts. And the dictionaries will have 2 entries, one V entry and one N entry. And let's start with that and see that we can use that in our algorithm. Let's start with our calculator. And then the variable, let's just call it table. And it's going to be list. We could also use a data grid. And V value and N value. And with a bit of luck, you should be able to copy and paste all of that. All these things should technically be numbers. It looks like we have the table down, and it evaluates to a list of entries, each of which has an N key and a V key. The V key contains the number, and the N key contains the Roman numeral, just like in this table. So in order for this algorithm to work, we're going to have to find the highest decimal value V that is less than or equal to the decimal number x. So we need a way of doing that. And one way of doing that is to say we're going to have find entry. Just going to be a function, and this is just given a number. It's going to find what we need. Now, in order to find the highest number that is lower than or equal to x, we're going to be going backwards, and the first number that we're going to find is going to be the one that we're going to use. If we were to go forwards, then the first number that we look at would always be fine technically, but we'd have to check the next one and then back off if it turns out that the next one is already above what we need. So to simplify things, we're just going to be going backwards until we find the first one that is lower than or equal than what we currently need. And for that to work, I'm going to quickly reverse the table. Just going to say, I could do this manually by just rearranging the entries, but there is another way of doing that. Let's call it R table for reverse table. And I'm just going to use the data reverse function and pass in the table. And before I can use any standard library functions, I have to enable their use for this data flow. And just to show you where this has come from, this is from the modules standard library. And there is a data library that, among other things, has a reverse function. So you can quickly find it here. And given a list, it returns a list that contains all the elements in the reverse order. It's exactly what we need. If we pass in a list, we're going to get the list, but with the items reversed. So let's do that. Quickly check if that works. So we start with 1,000 and then go. And then go down. And that looks good. Now when we're looking for the entry, we're going to use another function from the standard library, one that I find. And when we pass a list to the find function and a predicate function that will test each item, it will look through these items in order and pass each item into our predicate function as the first argument, and the predicate function will tell us if what we found is good. And the moment the data find function finds something that is good, it's going to return it to us, which is exactly what we need. So we're going to be iterating over our entries here, and we're going to look at the v value, and we're going to return the first one that is lower than or equal to what we need. So we define a function, we're accepting some sort of x, a long number x, and what we want to do is we want to call data find, and we're looking in our table, in the reverse table, and we're testing each item on each entry. And if we return true if the entry, looking at the v key, if that is smaller than or equal, less than or equal to Rx. Now we're going to need to find a way to testing this function. Let's call it on some numbers and see if it's going to work. So we're going to, let's say, find the entry for 83, which should be 50. Yes, we got the entry with the 50 in it. Or if we want to look for 7, then that should be 5. Yep. And if we're looking for 40, that should be exactly 40. Wonderful, that works. So we have that in place. Now we can do what the algorithm wants us to do. It says find the highest decimal value v that is less than or equal to the decimal number x. And its corresponding Roman numeral n, we found both of these. Now what we need to do is write the Roman numeral n, remember it somehow, put it into our temporary result, and subtract v from our x, and then repeat the whole process until we reach 0. So how do we do that? we want to repeat a process. So we want to repeat collecting our numerals until a condition is satisfied. The condition is that we reached 0. And there is a function in the standard library that allows us to do such things. It's called until. It's in a fun library. It stands for function. So in the function library, we're going to find things that are dealing with functions like chaining them. Or in this case, it repeats calling a function until a condition is true. So the way this works is we have a until function. We pass in a predicate whose job it is to tell us whether the loop should stop or not. If it returns true, we should stop the loop. Then we have something, an x, which is just any value we might want to pass into our function that is being called repeatedly, which is the last argument. And the way this works is until repeats calling f with argument x, and consecutive calls of f get the previous result as the first argument until the predicate function returns true. The way this is typically utilized if you want to create something like a loop is like in this case, in this example, we have a check. It says, okay, I'm testing my x, and if x sum is greater than 100, then I'm going to stop the process. And the initial x that is passed in is has a sum of 0 and an array of numbers apparently, and we have a function that is called next that is defined over there, and that gets called with this argument initially, and it returns another version of this which contains whatever we want it to contain. Now after that happens, the predicate function is called to check whether we should continue or not. And so in this case, we keep adding consecutive numbers until their sum exceeds 100. Let's try the same approach. So this item here that gets passed into our iteration function is I'd like to think of it as a tracker. It tracks what we're doing, and in our case, we're going to need our temporary result, and we need to keep track of the value of x. So let's try and do this. Let's have a function that's called toRoman. And we're simply going to start by saying, okay, we have a function here, we are accepting some sort of x. This is going to be the number we want to convert. And what happens next is we're going to define a bunch of helper variables. First, the one I'd like to call the tracker. This is going to contain the number that we're trying to convert, that's x. And I'd like to keep track of the ends that we are accumulating, and that's going to be an empty array. So this is our tracker. This is what's going to this is the structure that's going to be passed into our iteration function. Now we need a function that will tell us when to end. And when passed in a tracker, it will look at the num key, and if the num key is at 0, this is where we're going to stop. Next, we're going to have to define the function that is being called repeatedly, and it accepts the tracker as an argument. And it's going to first have to find the item that we need from our list. So let's see, let's call it entry, and the entry we're looking for is find entry. Defined the function already, and we're going to call it with whatever happens to be the number that we're tracking. And we're going to have to return a new tracker. So this is the structure for a tracker, and we're going to have to define the keys. Number is going to be the number we had before, minus whatever we found in the entry. The key for the entries was V. All right? And the ends, the Roman numerals that we're accumulating, that is going to be whatever we already have, and we're going to add something to it. We're going to add whatever the n was in the entry, and we're going to need this to be a list. And right now we are nesting a list within a list, but we want to append to it. So we want to split in the existing items and just append the last one that is new. And now that we've defined all that, we should be okay to say, now that all that is defined, let's call it. Let's put it into fun until the end condition, our tracker, and the function that we want to repeatedly work on the tracker. And so this whole thing is a function, and we need a way of testing whether it works. I'm just going to steal this entry and call it test, and then see if we can, what happens if we call our to Roman function and we pass in 15. I mistyped something somewhere. Oh yeah, it's not a variable definition, it's a key. Alright, so when looking for 15, num is 0 at the end of the process, and the ends we've collected are x and v. So maybe once we call this, let's just extract the ends. So we're going to get a list of x and v, and maybe we can just return a concatenation of all of that. So let's see if we have a concat for strings. There you go. So it's strings.concat. Given a list of strings, it gives us a string that concatenates everything. That's exactly what we need. So let's call strings concat on our ends. And here we go. So let's test it on something more complicated. 1996. That's 1,900. That's a 90. That's a 6. Wonderful. That looks good to me. So we are practically done. We just need to call our function here. So we're going to say we're returning a string. Let's call it Roman, and make this a formula where we just call bars to Roman, just to find that, and we pass in the decimal that is passing through. And when we run this thing, we're getting the expected results. And it should end with 1000, which should be an M. Okay, that looks good. Thanks for watching, and until next time.